Hello everyone, this is Pablo of VA3HDL. In this video, I will introduce the new features and improvements and do a quick code review for the ones that are interested. This is the video part number 3 on the preamplifier and equalizer, and I will put the links below for the parts 1 and parts 2 in case that you missed the first 2 parts of this series. Third part video, I'm going to use this computer headset that I modified to connect to the preamplifier, right, to the equalizer. This audio that you're hearing is coming through this PC headset that I mentioned I modified. Is connected to the preamplifier, and the preamplifier is connected into the computer. And I want to show that the audio that you are hearing is the complete unprocessed audio by the computer. The processing of the audio is done by the box, is done by the preamp and equalizer. Here on the computer, I'm not running any compression, as you can see here. I'm not running any noise gate. The noise gate is provided by the box. And also, I am not changing lows and high or any equalization in the headset in the computer. Everything you will see is done on the box. So I'm gonna remove this from the screen. And what I did to use this headset is, as you can see here on the screen, I split the connection between the speaker part and the microphone part. So the microphone is this gray cable, which I put an RG45 adapter, so I can come into the box, right, into the preamp and equalizer, and to monitor the audio when I'm setting up the equalizer, compression, etc., any other values, I am connecting it directly into the box. And when when I am happy with the settings, I remove the connections, and I can plug the connection into the radio directly to hear the audio coming from the radio if I want to. Now, before we jump into the list of new features and improvements, I wanted to show also what physical improvements the box has. So this little thing here, red and black, is a PTT button which I add because, for example, if I want to use this headset with the radio and I want to PTT, then the only two options that I have is use the Vox control on the radio, or now I can use this PTT button, or I can plug something in the back of the radio on the PTT port, like a foot pedal switch or something about that. But this is very simple, very easy, it's close to my hand, and I can PTT from here directly. So the other thing that the other thing I want to cover is in previous videos I couldn't show the two peak meters that it has on the screen. The yellow lines, the short one is the input. Let me zoom in. The short one is the input, and directly from the microphone, and the bottom one, the longer one, is the output. So you can see here the gain that is applied into the box, and you can at all the times you can see how the input and output compare. Of course, at the bottom you have here, like in blue, the spectrum analyzer. So in this part of the video, we will see all the new improvements and enhancements that I done on the final revision of the code. And to do that, let's jump into my website where I have all the details. So this is coming from my website, this page. You can find at va3hdl.com all these details. So again, this project is based on the Teensy 4.0 and the Audio Shield for the Teensy that is based on the SGTL 5000 audio codec IC. So in here, This is the entire feature list of this build, but I will just cover only the improvements since the last video. So the improvements are now in terms of volume and limiter controls. We add the auto makeup gain and the makeup gain. That is, when you're compressing, typically the normal compressor will compress the high levels, lowering them down to a normalized value. The auto makeup gain or the makeup gain, it will do the opposite. When you're compressing also, it will increase the lower levels of your audio up to the normalized value or threshold that you set up. So in this version, we add all these features that you can see here. So we add a noise gate, we add a compressor, and we add a limiter. The noise gate settings are attack, release, threshold, and hysteresis. So attack and release is how fast the noise gate you want to react and how long you want to keep the microphone open once that is triggered, and the threshold is of course the value that it will trigger the noise gate. The hysteresis is a range that you want to allow once it's open the noise gate to continue to be open. Then we have the compressor settings. So in the previous version, we just used the auto volume control as a kind of a fake or hack compressor for audio for levels that is built in on the chip. But in this version now it is a DSP, is a digital signal processing effect that does the compression on the audio in this version of the software. So the possible settings that you have for the compressor are, again, the threshold, the attack and release, the ratio, and the knee width. I'm not going to go into the details of what all these things mean, because you can find a lot of information about this already on YouTube, and I don't want to like waste time here, right? You can, very easy to find this information. The third functionality that it was added, part of the same dynamic effects software, is the limiter. So the limiter, it prevents to saturate the output, right? So you can say you can set up your top value for that, and then that will be your threshold. And then anything that goes above that, the volume is going to get reduced. So with that, you prevent to saturate and clip the audio. So the equalizer bands are the same. I haven't changed that, but that is customizable on the software. If you get the code and you want to modify the code, you can change these bands to be whatever you want. Two other features that are now added into this version of the software are the possibility to have 10 presets for different settings, different microphones, things like that. Like, for example, if I want to use a DID headset, or if I want to use, instead, I want to use a microphone like this type of Yaesu microphone, you can have settings for each one of them and switch them on the fly. And we will see that later in the video. And the last enhancement, it was to load the default settings presets on the code, and that is in case that you mess up with the setting and you want to start from scratch. You don't need to just turn the power on and off. You just can select this option from the menu, and it will reset everything back to the original values in the memory of the device. It's not going to delete or reset any of your presets that you have saved on the SD card. For this part of the video, now I am using this spectrum analyzer on the computer just to show the functionality that we're going to test. And now the first things that we're going to test is the noise gate. So now the noise gate is on, and I'm going to turn it off so you can see here how that works. So now the noise gate is off, and even if I am silent, you hear that background noise. And I turn it back on, and you see that background noise is gone. So that is the noise gate working. Now let me show the compression. So now I'm using the compression, and now I'm gonna turn the compression off. Now I'm not using the compression, and you can see here the audio level in this chart, how very low energy is in the audio. I'm gonna turn it back on, and now huge difference on the energy in the audio levels, as you can see here. I'm not using the equalizer. The equalizer is off, but I'm gonna turn it on now. So now the equalizer is on, and the settings that I have on this equalizer are for the frequencies above 1 kilohertz and up to 3 kilohertz. That is the frequencies that is improving, which of course is good for radio, for the Xing, but is not good for this video, so I turn it off. And this is the unmodified, unequalized audio from this microphone. So the last test that I want to do before we jump into the code, which is going to be the last part of the video, the last test I want to do is change this microphone with the Yaesu type of microphone that I have here with this one. So let's do that. So you will hear some clicking noise in now when I'm switching the microphone. And now I am using the radio microphone type it's very similar to the Yaesu microphone. So I'm using this one, and you can see clear difference between the frequencies and quality from one headset and the other. And this is the kind of things that you can correct and fix with this preamp, because it's even clipping, as you can hear sometimes. But this is the kind of things that you can correct with the preamp I was saying. And let me now go back to the computer headset. All right. Now I'm back with the computer headset, the PC headset modified for the radio. In this final part of the video, I will cover what changes I done, improvements over the code that was found on the book that I took this idea, this project is based on, and we'll review the code and where you can get that code. So this on the screen you can see this is the original configuration of the modules of the audio library modules for the Teensy that was used on the book. So you have your audio input, your mixer previous to all the 8 bands equalizer, and then the combination of the first four bands, the combination of the other 4 bands, then this gets combined again into one mixer, and then to the final mixer. And the reason they did it like this way in the book, because you can turn on and off the equalizer. So if you turn off the equalizer, the audio input is coming directly from this pipeline into the final mixer. And if you turn on the equalizer, this pipeline is turned off and the pipeline comes through here. So this is the original from the book. Okay, so I'm going to show in the next one is my modifications. So in my modifications, what I done is I realized that the mixer that they have in here, there was no needed. With the one mixer at the end, you can do the same things. Instead of turning off one input, you just need to turn off those 2, right? If you want to turn the equalizer off and the audio input, it will come directly into the this mixer. So that is the number 1 change that I did. Number 2 change, I put a peak meter on the input and I put a peak meter in the output, Like I explained, is the two yellow bars that you can see on the screen, right? And probably the most important change of everything that is on the original code is this library, the dynamics library that I found in GitHub. I didn't write this library, right? I was lucky I found it in GitHub. Somebody wrote that, which we're gonna see it, and I put that at the end. That the dynamics part, it should be always at the end before your output. And that dynamics library is what it provides compression, the noise gate, and provide the auto makeup gain, or the makeup gain and the limiter. Those are all the four functionalities provided into this library module for the library. Now, let's jump into the code. So very simple, similar code for every Arduino project. You have all your includes on the top. I use two libraries for the display. As you can see here, I use the Adaptor and the SD1306 ASCII. And the reason is the ASCII library is used for the menus, and the Adafruit library is used for the graphical equalizer. Sorry, for the spectrum analyzer. All the standard definition of constants and fixed values. More includes. Here is the configuration for the audio library, with some tweaks that I done manually. And let's go down. Here is the definition of all the default values for the sound, right? It's all here. And the reason I define it this way is if at any moment I want to go back to these original values without having to turn on and off the box, I can just select an option on the menu to load the default, and it will load these defined values. Then here I am getting those defined values, and I'm putting those on variables, because those are the variables that we're going to be changing when we tweak things from the menu. You have your bands for your equalizer. If you want to use different equalization bands, you can change them here, or you can add, if you want to add band or remove bands, you can do that here too, right? And all the definition. This is the definition of the octaves for the spectrum analyzer. I'm using a very simple 256 bits instead of 1024, just to keep it simple. And the next line of code, everything that you see here with functions called result, those are the functions for the menu, for the different options on the menu, how to turn on and off things and change things from the menu. All those functions are all for the menu. Everything that is displayed on the menu, everything that goes through the serial port, in the final version of the code, I commented out because this is only needed for debugging, doesn't add anything to the code unless you need to debug, right? So everything is turned off, commented. If you need to debug the code, you can uncomment those lines. This is all for the menu options that you control through the rotary encoder, right? This is the main menu here with all the submenus. Then the construction of the menu, and some other auxiliary functions. Then your setup, your common setup that you have in any Arduino project. With the serial, you can see here also commented. I don't turn on the serial port for anything. There's no need to do that. Some information when the machine is booting and for the screen, and that's it. Then the loop, and in the loop there is nothing, just pulling the menu and sensing if the spectrum analyzer is on and off. So if you turn it on, just showing that on the screen on top of the menu. That's it. This is the only thing that is on the loop. Why there is nothing else? Because the Teensy doesn't do much in the loop for the audio. Everything done in the audio is through interrupts and is on the built-in libraries. So everything is done through automatically for you. The next set of functions are specifically the audio functions. So the first one is to set all the default values to turn on the audio shield, all here with the settings. And the one thing that I skip is when in the setup. Okay, so when the system boot, it reads from the file the default settings, which are stored on the settings number 0. So the settings number 0 are the default settings, and those settings are loaded automatically. So anything that you put on the settings 0 are the default settings read from file, right? But if that file is inexistent, it will read the settings that they were in the defines that I showed before on the top of the code. So once that file is read, then the audio shield is using those values from the file is existing, the settings 0 file. Otherwise, it will use the default values in the defined lines on the top of the code. So this is all the configuration for the audio volume control built in on the chip. This is the settings. This is sets the levels in general for the microphone, in and out, line in and out, and all that. This set the input. If you can add more inputs, like if you want to have a line in input instead of a microphone, you can do that. In my hardware, I don't have that, but the option is in the code. This sets the equalization gains, and this function is the function that takes care of display the spectrum. This function is the function that reads from file from the SD card the settings. You can have from 0 to 9, so 10 settings files. This takes care of that, this function, and assign the values from the file into the memory variables. Write to file, it does the opposite. You can save the settings that you have in memory to any of those 10 files. And you can delete a file if you want to. You pick the settings, and then it's going to be empty. It's not going to be nothing there, right? So this is useful, for example, if you want to delete the setting 0, the default one. So the next time you reboot, it will just not load anything. It will just use whatever is in the defined instructions on the top of the code. And this is what I mentioned. This is the function that reset to the default values in memory, in case that you want to start from scratch. You mess up something, and that's it. That's everything. There is nothing else on the code except the effects library, the dynamic effects library, which it has been written by Mark Paquette. Now in this part, I want to show where you can find this code. This is available in GitHub. On VA3HDL GitHub, you can see the DSP preprocessor version 4. It has the main file plus the dynamics effect with the little tweaks that I done from the original created by Mark. And that's it, friends. I hope you like this video. Please, if you like, please subscribe, hit the like button. If you have any questions or comments, please do in the section below, and any links you will find on the comments description section underneath this video, and the links for the previous 2 parts. So thank you so much for watching, and until the next time.